So the title of my project is Waves of Polymathy, exploring and applying various wave properties by me, Daniel Bustamante. I am currently in the 8th grade. So, what are waves and what types are there? Waves are a disturbance that propels and launches from its original source. The three different types of waves are longitudinal, transverse, and surface waves. This is a longitudinal wave. This demonstration shows that the particles move from left to right, or in oscillatory motion. This second demonstration shows how the particles oppose the waves, which the particles are oscillatory, or back and forth motions, and the waves are the propagation, or the disturbance. The compressions refer to the parts that come close together, and the rarefactions are the parts that spread. As shown, this is a transverse wave, which has an up and down motion. This demonstration also includes propagation like longitudinal waves, but instead of the compressions and rarefactions, the particle displacement, or movement, is perpendicular to the propagation. This is a surface wave demonstrated with water. Different from longitudinal and transverse waves, the particles move in circles. The circular motion decreases the deeper you are in the water. What type of wave is most involved in our everyday lives? If you guessed transverse waves, then you would be correct. Reason why is because water is a type of transverse wave, specifically the movement. The question of this experiment is, how do longitudinal waves affect transverse waves in terms of amplitude? So what I researched is the examples of each of these waves. An example of a longitudinal wave is a ringing bell. An example of a transverse wave is the movement of water. And an example of a surface wave is the ocean and its gravity. Some of the careers that deal with sound waves are audio engineers, audio broadcast engineers, mastering engineer, live audio engineer, game and audio, design engineer, audio production assistant, post-production expert, and sound designer. Waves could be in everyday life. Speaking with your vocal cords, music from a speaker, or even a church bell are just a few examples. So this experiment would be about how speakers affect transverse and surface waves from water. The frequency of the water would be measured at different frequencies from the speaker, ranging from 20 Hz to 20,000 Hz. So I hypothesized that the lower the frequency, the higher the amplitude of the water. So the higher the frequency, the lower the amplitude of the water. The materials used in this experiment are a container of water, a notebook, and a speaker specifically from an iPhone. So what frequency do you think will have the most effect on the water? We'll find out after this experiment. These are the photos. I observed that when the frequency was at 20 Hz, the water was slightly moving. When the frequency was at 200 Hz, the water gained more amplitude. However, when the frequency was increased to 2000 Hz, it was moving less and less. Lastly, when the frequency was at 20,000 Hz, it was not moving at all. These are my charts and results. So I conclude that the lower frequencies affect the water the most. The reason is because they have longer wavelengths. The sound penetrates the water and loses less energy compared to the higher frequency waves, which have shorter wavelengths. So how does this apply to the real world? Waves have a wide range of real-world applications, such as music optics, tides, cooking, and earthquake detection. It could help with research about the ocean, like researching how sound affects ocean behaviors. Careers that deal with waves are electronic and communication engineering, oceanography, seismology, and wave engineering. And these are all of my citations in APA format.